Namaste ma'am. My name is Aasritha Rajaram and I am from class 9D. I would like to present my science project. What if you are practicing for your 200-meter race and suddenly if anyone asks you to turn immediately to the right, will you be able to do it? Yes, you can do it, but can you do it immediately? The answer would be no. As every object will continue to do what it's doing, if it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But only an unbalanced force can change this. If it's at rest, an unbalanced force acts on it, it will move. If it's at constant motion, an unbalanced force acts on it, it may accelerate or change the direction, and this is nothing but the Newton's first law of motion. An object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. It means objects continue to do what they are doing unless some external unbalanced force acts on them. In the first law of motion, if the forces are balanced, the acceleration will be zero. If the forces are unbalanced, there will be acceleration. Guess what are the two factors on which acceleration depends on? They are net force and mass. Acceleration depends directly on net force and inversely on the object's mass. Mathematically, the second law of motion can be written as acceleration is equal to net force by mass. In simple words, acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. Or we can understand it like net force is equal to mass into acceleration. For example, if the mass of an object is 10 kgs and the acceleration is 10 meter per second square, the net force will be 10 kgs into 10 meter per second square, which will result as net force is equal to 100 newtons. What happens when you place an object on the table? The object exerts a force on the table and the subject exerts an upward force on the object. There are two forces that can result from the interaction: a force on the table and the force on the object. The magnitude of the two forces are the same, but the directions are opposite. These forces are called action or reaction forces. The force exerted by the object on the table was an action force, and the force exerted by the table on the object is the reaction force. So Newton's third law of motion is every action has an equal and opposite reaction. For example, when a frog is swimming, it pushes the water back and the water pushes its body forward.